Can commercial spaceports survive without government money? At sunrise, a launch pad can look like the center of the future. The service tower rises above an empty plane. Floodlights illuminate the vehicle assembly building. Miles of fencing mark the boundary between ordinary territory and the machinery of spaceflight. Somewhere nearby, a control room waits behind darkened windows. There is only one problem. No rocket is scheduled to launch. Perhaps one flew 6 months ago. Another might arrive next year. The spaceport director has a calendar filled with industry conferences, site visits, and hopeful conversations with launch companies whose vehicles remain several years behind schedule. Maintenance crews still have to inspect the electrical systems. Security officers still have to patrol the perimeter. Insurance still has to be carried. Roads still have to be repaired. The launch pad may be empty, but the bills have achieved a reliable cadence. This is the strange economic problem facing commercial spaceports. Governments around the world want them. Regional authorities advertise them as gateways to the space economy. Local politicians treat a spaceport license as if it were an oil discovery beneath the county courthouse. Yet a license does not create launch demand. A runway does not create a spaceplane. A concrete pad does not create a customer willing to pay enough to keep the facility alive. The central estimate for this episode is straightforward. Most commercial spaceports cannot survive as ordinary private businesses funded mainly by launch fees. The demand is too concentrated. The capital costs are too high. The launch companies often control their own infrastructure. A viable spaceport usually requires government missions, public funding, or a broader aerospace business that earns money during the long silence between launches. That does not make spaceports useless. It means we have been using the wrong economic analogy. A commercial spaceport is rarely an airport with taller vehicles. It is closer to a naval base combined with a weapons test range. Its value comes from readiness, geography, security, and the ability to support unusual operations on demand. Those qualities can matter enormously to a nation. They do not always produce the sort of monthly cash flow that pleases a private investor. The distinction matters because the United States now has a growing network of licensed commercial spaceports. Some handle regular operations. Others have spent years waiting for the vehicle or tenant that was supposed to turn concrete into commerce. The question is no longer whether governments can build spaceports. They clearly can. The harder question is whether the spaceports can build businesses. Begin with the revenue model. A spaceport can charge an operator for access to a launch pad, runway, integration building, tracking network, or restricted operating area. It may collect rent from tenants. It may provide fuel services, security, payload processing, or mission support. In theory, this resembles an airport collecting landing fees and leasing terminal space. The similarity collapses once cadence enters the equation. A busy commercial airport can handle hundreds of aircraft movements in a day. The same runway supports many airlines. Aircraft arrive with standardized interfaces. Ground crews know how to refuel them. Passengers pass through a familiar terminal process. One airline may fail, yet the airport can court another because numerous operators use comparable equipment. Orbital launch does not work that way. A rocket may require a purpose-built mount, specialized propellant equipment, unique software, protected airspace, and a safety case tied to that vehicle. The pad that supports one launch system may require expensive modification before it can support another. Even vehicles in the same broad class can demand different electrical connections or flame management structures. A rocket pad is therefore less like a gate at an airport and more like a tailored industrial machine. The customer does not merely park there. The customer shapes the facility around the vehicle. That creates a severe bargaining problem for the spaceport. The operator with the rocket has leverage because rockets remain scarce. The spaceport without an operator owns an impressive collection of fixed costs. A launch company can threaten to move elsewhere or build its own site. The spaceport cannot move its runway 1,500 miles closer to the customer. This is why launch demand tends to cluster. SpaceX did not respond to the growing number of American spaceports by distributing Falcon 9 launches evenly among them. It concentrated operations where its infrastructure, range access, supply chain, and workforce already existed. Rocket Lab built much of its identity around a dedicated launch complex in New Zealand, then added access to a government range in Virginia. Blue Origin developed private infrastructure in West Texas for New Shepard while building orbital facilities around Cape Canaveral. The most successful launch companies often prefer control. They want authority over pad modifications, security procedures, scheduling, and turnaround work. A public use spaceport may promise flexibility. The operator may hear delay, compromise, and a committee meeting in a windowless building. A new spaceport therefore enters a market in which the strongest customers already have favored locations. That leaves smaller launch companies. On paper, this appears promising. A new small launch provider may need a site. The spaceport can offer favorable lease terms, political support, and infrastructure without requiring the company to fund an entire range. The difficulty is that launch startups fail with impressive regularity. Their schedules slip, capital disappears, test vehicles break, engines reveal personalities that were absent from the investor presentation. The spaceport can spend heavily preparing for a tenant whose first orbital launch never occurs. Even when the company survives, the launch rate may remain too low to support the site. Suppose a spaceport charges several $100,000 in direct fees for each mission. That sounds substantial until the facility's annual cost is considered. It may need a permanent fire service, range safety personnel, communication systems, environmental monitoring, and specialized maintenance. A handful of launches can produce headlines while leaving a large operating deficit. A launch is spectacular. A balance sheet is immune to spectacle. The economic case becomes weaker when planners assume that dozens of new launch companies will all reach flight status. Many spaceport proposals were built during periods when small launch appeared ready to become a crowded market. Hundreds of small satellites needed rides. Venture capital was abundant. Regional governments expected a fleet of new rockets searching for available pads. The market developed differently. Rideshare missions allowed small satellites to fly on larger rockets at lower prices. Several dedicated small launch companies failed or withdrew. SpaceX absorbed a large share of demand through frequent missions. A launch market that looked ready to scatter across many sites instead became concentrated around operators with scale. This is the first principle of commercial spaceport economics. Projected satellite demand does not automatically become local launch demand. A satellite may be built in Colorado, tested in California, integrated in Florida, and launched on a vehicle whose provider owns most of the ground equipment. The economic activity exists. The spaceport seeking a tenant may still receive none of it. The same mistake appears in regional economic studies. A report may begin with the total size of the global space economy, then suggest that a local spaceport can capture some portion of that growth. The arithmetic looks persuasive because the global number is large. The causal mechanism is frequently missing. A county does not gain a share of satellite communications revenue merely because it pours a launch pad. A launch site captures spending when a real operator performs real work there. The work must occur often enough to support permanent jobs. Those jobs must remain local rather than arriving temporarily with the launch crew. The distance between those conditions and a ceremonial groundbreaking can be wider than the Atlantic. This explains why many commercial spaceports seek an anchor tenant. The anchor tenant promises activity. It signs a lease, influences the facility design, and gives public officials a recognizable company name to place on economic forecasts. The arrangement can work. It can also trap the spaceport inside the business fortunes of one company. The clearest American example is Spaceport America, New Mexico. The facility occupies a remarkable site. It has open desert, restricted airspace, and a long runway built to support horizontal operations. State and local governments invested more than $200 million in the project. Virgin Galactic became the anchor tenant under a long-term lease. The strategic logic had merit. Virgin Galactic needed a base for commercial human spaceflight. New Mexico could offer airspace that would be difficult to secure near a dense population center. The state would gain a recognizable space company, technical employment, and a position inside a growing industry. The facility was real. The spacecraft were real. The flights eventually became real. The cadence was slower than the original political vision. Virgin Galactic carried out a limited series of commercial missions before pausing operations to develop its Delta-class spacecraft. That development period left Spaceport America with reduced activity from its most prominent tenant. The runway remained. The hangar remained. The operating expenses displayed admirable loyalty. This does not prove that Spaceport America failed. The facility hosts other users and supports testing. Its economic impact extends beyond launch fees. Virgin Galactic may return with a spacecraft designed for a higher flight rate. A long-lived spaceport has to be judged over decades rather than a single, quiet year. Yet the case reveals the anchor tenant risk with unusual clarity. When a spaceport is designed around one company, the company's technical schedule becomes the region's economic schedule. A delayed spacecraft becomes delayed rent growth. A redesign becomes a quiet terminal. A weak corporate balance sheet becomes a public policy problem. Airports face airline bankruptcies, but their infrastructure usually remains useful to other carriers. A specialized spaceport may have fewer substitutes. Another operator cannot simply arrive on Tuesday and begin flying from a facility shaped around a different vehicle. This dependency changes the meaning of public support. Government funding is often described as temporary seed capital. The state builds the basic infrastructure. Private launch activity then arrives. Revenue grows. Public dependence declines. That sequence sounds tidy. Spaceflight has a habit of kicking tidy sequences down the stairs. The initial facility may need modification once the vehicle design changes. Environmental reviews may take longer than expected. The anchor tenant may demand new infrastructure. A second tenant may require equipment incompatible with the first. The public contribution continues because abandoning the project after the first investment would make the earlier spending look wasted. Economists call this a sunk cost problem. Politicians call it the next phase. The result is a spaceport that remains commercially branded but publicly sustained. Its defenders point to regional employment, research activity, or strategic value. Its critics point to the absence of private operating independence. Both may be correct. A facility can generate public value without being a self-supporting business. A military airfield does not need to earn a profit from landing fees. A national laboratory does not need to sell enough visitor tickets to fund particle physics. A strategic port can matter during an emergency, even if its commercial traffic remains modest. The confusion begins when governments justify a strategic asset using the financial language of a shopping center. If the real purpose is sovereign launch access, state the purpose plainly. If the purpose is regional aerospace development, measure engineering work and local payroll. If the purpose is commercial profit, demand evidence that customers will pay enough to cover the facility's cost. Those are different tests. Blending them can turn every outcome into a declared success, which is a wonderful arrangement for speeches and a poor method for allocating capital. Spaceport America also points toward a better model. The facility has increasingly marketed itself as more than a departure point for spacecraft. Its runway and restricted airspace can support flight testing. Its remote location can support sensitive operations. Companies can use the site for research that never crosses the boundary of space. That broader identity matters because launch is episodic. Testing can be continuous. A company developing a high-altitude aircraft may need weeks of operations. A defense customer may require protected airspace for an experimental system. A drone manufacturer may need a remote range. A propulsion company may require controlled ground testing. These activities are less cinematic than launch. They are often more useful for paying salaries in February. The commercially stronger spaceport behaves like an aerospace field laboratory. Launch remains the defining capability, yet the facility earns revenue from adjacent work that uses the same geography and security. This is where the airport analogy finally becomes dangerous. An airport is organized around transportation throughput. A spaceport should often be organized around mission support. The customer may need integration space rather than a launch slot. It may need secure telemetry rather than a terminal. It may need a remote test corridor rather than a ride to orbit. Once the site begins solving those problems, launch becomes one product inside a broader business. That model still faces limits. Research activity can migrate. Defense contracts are uneven. Restricted airspace is valuable only when customers have programs ready to use it. The spaceport requires personnel who understand technical operations rather than a staff built mainly around property management and public affairs. Still, the model offers a path beyond waiting beside an empty pad. The second path is government launch. This is where commercial branding meets strategic reality. The Pacific Spaceport Complex in Alaska offers a useful contrast. The site on Kodiak Island supports launches into high-inclination trajectories. Its geography provides access over the ocean and makes it valuable for missions that require northern orbital paths. The spaceport has supported government work, including missile defense testing and responsive launch missions. Those customers do not select a site because it promises tourist traffic or a pleasant terminal. They select it because the geometry works and the mission can be protected. That produces a different economic foundation. A defense customer may pay for readiness. It may fund site upgrades for a particular vehicle. It may value the ability to launch on a compressed schedule, even when the annual mission count remains low. Commercial investors usually dislike idle capacity. Military planners sometimes purchase it deliberately. A launch complex kept ready for a contingency resembles a fire station. Its economic value does not depend on keeping the trucks permanently on the road. The capacity matters because it can respond when required. This is especially relevant as the United States examines tactically responsive space. The Department of Defense wants the ability to replace or augment satellites quickly after a failure or hostile act. That requires launch vehicles, prepared payloads, regulatory authority, and available sites. A rocket waiting for a pad is merely a tall cylinder with an urgent calendar. A distributed spaceport network could therefore have national security value, even when several sites operate below commercial capacity. A second launch location complicates adversary planning. It provides options after weather delays, range congestion, or physical attack. It can support orbital inclinations unavailable from the primary site. The government may decide that maintaining such capacity is worth paying for. That is not commercial independence. It is strategic procurement. The distinction should be kept clear because government work can support a site while distorting its apparent market strength. A spaceport may report substantial revenue, yet most of that revenue may come from public contracts. The operation survives, but it does not demonstrate that private launch demand can support the infrastructure. There is no shame in this arrangement. Confusion is the more expensive vice. National governments have always funded transport infrastructure with strategic characteristics. Ports, rail lines, airfields, and highways often receive public money because private investors could not capture their full public value. Spaceports fit comfortably inside that tradition. Their benefits can include national access to orbit, a trained local workforce, test capacity, and emergency launch options. Those benefits extend beyond the direct customer paying a launch fee. Private finance will underprovide them because the investor cannot send an invoice to national resilience. The case for government support therefore becomes strongest when the site serves a defined national requirement. The case becomes weakest when officials begin with a desire for a local spaceport and search afterward for a strategic explanation. One sequence begins with mission analysis. The other begins with a logo. This brings us to the central commercial question. Can a spaceport survive without government money? A small number can under favorable conditions. The site needs a customer with a real vehicle and repeated demand. It needs infrastructure matched to that vehicle. It needs geography that offers a useful launch azimuth or protected operating area. It needs enough adjacent business to carry the facility through delays. Most important, it needs a reason for the customer to remain. That reason may be ownership. A launch company operating its own site has an incentive to keep the facility active because the spaceport exists as part of the launch business. The economics are internal. The company does not need the pad itself to produce an independent profit. It needs the pad to support profitable launch services. This is why vertically integrated sites have an advantage. A standalone spaceport sells access to infrastructure. An integrated launch company sells access to orbit. Customers care about the second product. The pad is a means to that end. A privately operated launch site can therefore survive because its revenue arrives through the rocket service, rather than through rent charged to the rocket company. The economic unit is the mission, not the real estate. Independent public-use spaceports occupy a weaker position. They must persuade launch providers to use infrastructure those providers do not control. They then earn a fraction of the total mission revenue while carrying substantial fixed costs. This is similar to owning a concert venue in a town with one band, except the band requires a custom stage and occasionally explodes. The model improves when the spaceport becomes difficult to replace. Geography can create that position. An equatorial site offers performance advantages for certain missions. A coastal site may permit safe downrange flight. A northern site may provide direct access to polar orbit. Existing restricted airspace can reduce operational conflict. Regulatory speed can also matter. A site with experienced safety personnel and established procedures may reduce schedule risk. Launch operators will pay to avoid delay because an idle rocket consumes money at a speed normally associated with government software contracts. Workforce depth matters for the same reason. A site near propulsion technicians or range engineers can solve problems faster than a remote facility that imports every specialist. These advantages create a genuine product. The spaceport is no longer selling concrete, it is selling schedule confidence. That is one of the few services for which a launch company may pay a premium. There is another possibility, the spaceport as an industrial district. Under this model, the facility earns much of its value before the rocket reaches the pad. A satellite company leases clean room space. A propulsion firm conducts engine tests. A launch provider assembles vehicles nearby. A defense contractor operates a secure mission center. The Spaceport Authority collects rent and service revenue across the development cycle. Launch activity then anchors a local production cluster. The logic resembles a seaport surrounded by warehouses and ship repair yards. The port's value is found in the network of work around the waterline. This is difficult to create by decree. Companies locate near a spaceport when proximity solves a real problem. Moving a large rocket stage over public roads is expensive. Locating final assembly near the pad can make sense. Keeping payload processing close to launch reduces handling. A company with frequent missions may value immediate access to range personnel. A low-cadence site does not generate the same pull. A satellite manufacturer has little reason to move beside a pad used once a year when most of its customers launch elsewhere. The industrial district strategy therefore follows successful operations. It rarely substitutes for them. Public officials often reverse the sequence. They build speculative facilities, then expect tenants to arrive because space is growing globally. This is property development wearing a flight suit. The better approach begins with a specific operational demand. Infrastructure is added when a customer has demonstrated need. Buildings remain adaptable. Contracts place some risk on the tenant rather than leaving the public authority to finance every specialized requirement. This produces slower announcements. It can produce a stronger spaceport. The temptation to build ahead of demand is understandable. Launch infrastructure requires long lead times. A government that waits for certainty may miss the customer. Yet building too early can lock the site into obsolete assumptions. The solution is modularity. A spaceport can invest first in assets with multiple uses. Roads, secure communications, basic utilities, and flexible integration buildings can support varied tenants. Specialized launch equipment should follow a committed vehicle program. A pad designed around an imaginary rocket is a monument to engineering fiction. The strongest spaceport strategy may therefore look less ambitious at the beginning. It starts with range services. It supports testing. It builds secure facilities for customers already operating in the region. Launch capacity grows from actual demand, rather than from a forecast that treats every proposed rocket as a future tenant. This approach lacks the visual grandeur of a completed terminal. It also avoids polishing floors for passengers who have not been born. For defense planners, the implications are direct. A national spaceport network should be evaluated according to mission utility rather than launch count alone. Some sites may deserve public support because they provide geographic options or responsive capacity. Those sites should be funded through transparent readiness agreements. Pretending that commercial tenants will eventually cover the cost can leave strategically useful infrastructure fragile. A wartime launch network also requires more than multiple pads. The nation needs compatible vehicles, transportable ground equipment, trained crews, and payloads designed for rapid processing. A nominally available spaceport adds little if each operator requires years of site preparation. Resilience comes from operational interchangeability. That may require the government to encourage common interfaces or fund mobile systems that reduce dependence on permanent pad equipment. The objective is to make the launch network behave less like a collection of private kingdoms. For commercial operators, the estimate is harsher. A spaceport proposal should be judged by contracted activity rather than expressions of interest. The key question is whether an operator has a funded vehicle and a credible launch schedule. A memorandum signed beside a scale model is not revenue. It is decorative optimism. Investors should examine who pays for site-specific modifications. They should ask whether another customer can use the infrastructure if the anchor tenant fails. They should test the business against a 2-year launch delay because 2 years is a brief afternoon in aerospace development. For state and local officials, the choice is between clarity and theater. A spaceport can support aerospace employment. It can attract testing activity. It can become part of national defense infrastructure. These are legitimate public purposes. Each requires a different funding case. A region seeking high-wage technical work may gain more from a propulsion test center than from a rarely used launch pad. A coastal county may discover that satellite data companies create more durable employment than launch tourism. The prestige of the word spaceport can pull attention away from less glamorous investments with stronger returns. The rockets receive the photographs. The clean rooms often pay the mortgages. Over the next decade, the commercial spaceport market is likely to separate into three broad outcomes. A small group of high-cadence sites will dominate orbital launch. They will benefit from established operators, mature ranges, and accumulated technical experience. Their challenge will be congestion rather than abandonment. Another group will survive as specialized government and test facilities. They may launch infrequently, yet remain valuable because of geography or protected operating areas. Their public funding will continue because readiness is the product. The weakest sites will possess licenses without missions. Some will pivot toward drone testing or aerospace research. Others will continue searching for an anchor tenant while maintenance costs quietly consume the original political enthusiasm. The indicator to watch is not the number of announced spaceports. Watch the concentration of launches. Watch where operators invest their own capital. Watch whether a site earns recurring revenue when no rocket is present. A spaceport has a viable business when its value survives the scrub. Government money will remain part of the sector because space launch carries strategic benefits that private markets cannot fully price. The serious policy question concerns what that money purchases. It can purchase ceremonial infrastructure built around distant demand. It can also purchase national capability tied to real missions. Those two facilities may look identical from the highway. Their calendars tell the truth. A launch pad is a promise written in concrete. Whether that promise becomes a business depends on what arrives after the ribbon is cut.